Hello, Mario! In this video we're going to be looking at the vertical alignment and how we can capture that. In the first instance we're going to be looking at creating the basis for the long section, and in particular creating the existing surface, or the shape of the existing surface, and then we're going to be having a bit of a look at the alignment. Now over here is my basic information that I have. This is where everything is live, where the coordinates are in the right place, but I've pared it down so that what we're looking at here is just the surface information. I want to gather the surface information. So here I have the basic roading stuff. I've turned off a lot of the layers because just to get down to the clear stuff we want. So here we have the center line of the existing road, and then we have the contours, where the contours intersect what is the horizontal alignment. So what we have to determine now is the existing surface based on this, where these contours intersect the alignment. But we must remember that through this existing road here we have a typical cross section. So I've given the cross section a greater priority over the actual contours here, because that is a more accurate representation of what's going on. Now I need to do a lot of measurement and add a lot of information. So what I've done is I've just made a copy here of the actual what I call the live area here. This is where the coordinates are true, and I've just made a copy over here because for the vertical alignment the coordinates are not important. We don't need to know the coordinates. All we're working with is the heights. So I've gone over here to the long section, and this is where I do my work, and this is more by way of a calculation. So I'm just going to put that up there into I'll just go back to model space, I think, and just go Control Z E, or get the back into paper space, just to get this in here, and then I will maximize the viewing area like so, like that there. So that should be good, and I'll just lock that in place so we don't have too much problem with it. So it's not at any particular scale at the moment. So let's go and have a look in there and see what I've done. So so what I've actually done there in this copy of the original is I've gone through and I've worked out all of these distances here. This based on their horizontal alignment. So from that I would be able to determine the chainages. So I've worked out the distance, say for instance to this contour here, and from that contour through to there. I'll just one of the things I notice here is that go to the home tab, my line weights here need to be reset back to a default of 0, and just to make things easier. So just go to my line weight settings and display line weight. I'm just going to have my default of 0 because it doesn't seem to like it. It doesn't seem to hold that setting for some reason. Okay, so that makes it a little bit easier, and in fact I'll probably just turn the line weights off just to make it somewhat easier again. Now, so there I've gone through and I've measured all of these little distances, so that from that we can put that together and work out the chainage of each intercept of the contours. Now when we come up to the curve, of course, that's a bit of a different story. because we want to measure the arc lengths. And the way that I measure the arc lengths is to draw a little arc between each point. The way I draw the arc is with the 3-point arc, which is this 3 points here, and it will draw an arc. Perhaps could give an example here on one of the larger ones. Just escape out of there. So we use the arc tool, and we just put 3 points on the arc, start anywhere on the arc, and then at the end or at the intersection. You have to be very careful about these and make sure you zoom in and get exact intersections, otherwise you can get some small errors creeping in. And then there's the arc there. I'll just click on one of these arcs. Looking at the properties, you can see that one's not a very particularly good one, because the radius is 67.412, and we know that it should be 70. So it probably, I'll just delete that one and go back to one of the original ones there, and that's not a very good one either. And so we'll just see what we can do. Control Z. Just try this again. So there's the start point there, right on there. Should be on the arc there now, and that should be a quite clear intersection. So we need to possibly zoom in quite closely to make sure that we get these right. So it's the apparent intersection that we're after, like so. Oh, doesn't look like it's apparent intersection there. And then if we click on that one there, well, that's got a better radius, 69.863. But you can see the importance of getting these exactly right. And one of the other things that I also have done is although we don't have heights at the actual points on the horizontal alignment, the horizontal points, I have keyed into those to make sure that our measurements are reasonably correct within a few millimeters. So that's how we're collecting the surface information. Now, how I've collected that is I have gone and used an Excel spreadsheet, and I'll just pause for a moment and then I'll come back. And so here we have my Excel spreadsheet where I've put in the chainages down here. So these are the key chainage points, for the most part, that come from the horizontal alignment. And then here are the little distances that we've measured to the contour intervals. And you can see that what I've done here is I've put the distances and then I've added them up here, so you can see that we've got a correlation there with that point and that point there. When we come down here, we've got 55.135. We've got a bit of a millimetre difference there, and this is here is where we have to be, very careful with those measurements and zoom right in to make sure that we're getting the correct intersection and what have you. And moving on down, so I've measured them all. We can see here from the tangent points that these are all little arc distances here around the arc. And keying into the 60, we've got 1 millimetre, 2 millimetres there, a couple of millimetres there, 3 there, 2 millimetres there, 2 millimetres there, and so on. And then I've gone right through the end to the end of the surface or the contours. And then over here, a lot of these columns here have been added subsequently with further calculations. But down through here is where I've got the surface through here, and yes, the 27033 there is the centre line of road 1, and I've shown. I'll go back and show how I calculated that. and then these other ones here, of course, are contour, just the straight contour intercepts. The red numbers are ones that I've added in afterwards, where I have interpolated, once I've drawn up the height, or drawn up the surface, I've actually interpolated back to get what the actual surface heights are at these points, but these are not, so these are the pure contour intervals here. So I've put all that data into a spreadsheet, and we'll be using the spreadsheet quite a lot further on. I've also included what's going on in the horizontal alignment. So here we've got a straight in through here, and then there's the curve. This is the curve here, going from a tangent point to tangent point. I've got to obviously sort something out a little bit there. Things have got a little bit out of kilter, but nonetheless, and then we're moving through, and these are some other bits and pieces of the design that I'm working on with regards to the long section. So we'll just minimize that, and here we are back at the, hopefully back at the thing. Now what I've done here, just to get a value for the, to where that 27033 came from, is here's the centre line here. So I've measured this distance here from the 27 contour up to the point, and then from there up to the next contour, which is the 27.2. So the RL of this point here would be 27 plus 3.329, this value here, divided by the total, which is 3.329 plus 16.819, which appears to would be around about 20, and then multiplied that by 0.2, and that'll give us, you know, the fraction of the distance of the 0.2 rise from there to there, and that gives us 27.033, which is the starting point for the contour there. And then there's all these little measurements. I measured the arcs and keying in with the actual horizontal alignments and so on there, and what have you. So that there is how I have managed to scale off and tabulate on an Excel spreadsheet the existing surface from which we're going to work on to do some more work on the vertical alignment.